You have to remember that velocity includes the speed and the direction you are going, whereas speed will just be how fast. Acceleration can include the speed, the direction, but mainly where you are going. For example, 25 kilometers per hour to the north would be an example of velocity, because I'm telling you my speed and my direction. If I just said 45 kilometers per hour, that would just be my speed. Now, if I said 65 kilometers per hour around the corner, that is going to be acceleration, because it's telling you how fast and where we are going. We are going around the corner. So that is velocity, speed, and direction. Also, we need to remember that speed, we can find the speed by taking our distance and dividing it by our time. Now, okay, now let's talk about mass. We know that according to Newton's second law, force equals mass times acceleration. So, and what this means is that the greater your mass and the greater your acceleration, it's going to be more force. One thing you need to be careful of on the test, there is a question that has 2 steps to it. So here's the thing. If you have a train contains 5 cars that accelerates at 20, oh, sorry about that, guys. Meters per second squared, suddenly stops. The mass of one car is 300 kilograms. How much force? Okay, so in order to complete this problem, the first thing we have to do is first of all, we know that our formula is going to be F equals ma. So force equals mass. Our mass is not just 300. We have 5 cars. So what we have to do first is we have to take 5 times 300, which equals 1,500. So this is going to be 1,500 times 20 meters per second. So it's going to be times 20. So we take 1,500 times 20, which gives us 30,000. So our answer for this one would be 30,000 newtons. We would have 30,000 newtons of force. So make sure when you are looking at your problems that you double check that it's just of how many cars. As I said, there's one problem that we have on the test that contains more than one car. So now let's talk about unbalanced forces. First of all, we know that a balanced force will move at a constant speed. So an unbalanced force will accelerate. Also, we need to remember that let's do a problem together. If I have a fish, yes, this is going to be a terrible fish. So but I have a fish here, and he is swimming upstream with 25 newtons of force. However, the water is coming back against him with 10 newtons of force. Now, I may be asked, what would happen to this fish? Well, first of all, we know that he would be moving with about 15 newtons because we would have to subtract the 25 from the 10. What would happen if this increased to 20 newtons? The fish would slow down. Or he would have to use more energy to stay at that speed. So when you have a question like this, you just need to look through all the different options they give you to figure out what is going to happen if you increase something or you decrease something. And you can remember that balanced forces are constant speed. Unbalanced forces will accelerate. Now that may be a negative acceleration or a positive acceleration. We don't know. We also need to know that with a balanced force, the net force is going to equal 0. And, or the object could be at rest. Whereas with an unbalanced force, it's going to accelerate, or it could change direction, or there could be a change in speed, and the object's net force will be greater than 0. Okay, those are all to do with balanced and unbalanced forces. Also, another thing you have to consider is if we have a box here, and let's say that these are my boxes, and this is my mass. These are my masses over here. We've got box 1, 2, 3, and 4. And box 1 weighs 10 kilograms. Box 2 weighs 3 kilograms. Box 3 weighs 30 kilograms. And box 4 weighs 15 kilograms. Okay, we know that box 3 is going to accelerate the fastest because it's the lightest. Which means that this one will be the slowest and require the most force because it's heaviest. And then your 10 and your 15 kilogram boxes would just fit in around there. We know that a 10 would require less force than the 15. The 15 would require less than the 30. The 3 will require the least amount of force. So you have to be careful when you're reading questions like this, that you think out what are they asking you, and just compare your boxes. Okay, so now let's talk about Newton's law. Okay, Newton's laws of motion. The first law, I guess you need to be able to see what I'm writing, don't you? The first law is the law of inertia. The first law says that an object in motion wants to stay in motion. And an object at rest wants to stay at rest. So, if you're riding your bicycle, yet again, this is a terrible bicycle, but it'll get the point across. If you're riding your bicycle down the street and you hit your brakes really quickly, and you're up here on your bike and you are riding along, if you hit your brakes, you are going to continue to go this way while the bike stops because of the law of inertia. You always want to continue going in forward motion. Remember, that's why when you hit the brakes, you fly forward. Second law is the one that says force equals mass times acceleration, which we just talked about a few minutes ago. Now, the third one is the one that's tripping us up. Newton's third law is the action-reaction law. Here's what we have to understand about the action-reaction law. If I am hitting a bat, if I have a bat, I'm hitting a ball, not hitting a bat. If I've got a bat and I have a ball that's coming, yet again, I know this is terrible drawing. If this ball is coming towards my bat, the action is going to be my bat hitting the ball. The reaction will be the ball hitting the bat. So the ball comes this way, and then it's going to go this way. Action, reaction. It has to be the same two things involved. It's just like a trampoline. If you have a trampoline and you're jumping on it, bouncing against the trampoline is the action, and it pushing you back up is the reaction. You sitting on a chair. If you're sitting on a chair, the action is you pushing down on the chair. And the reaction is the chair pushing up on you. So action, reaction, it has to be the same objects. So it can't be something like the ball hitting the bat and then gravity pushing the bat to the ground. That's not action, reaction. It would be like, for instance, if you have your boat and you're going down the river and you're in here and you've got your paddle. Action reaction says that when you push this back against the water is pushing back against the paddle. And therefore, that is why you move. So, Newton's third law is action-reaction, and it has to be the same two objects. Just like, for instance, if I jumped off the boat here, when I push off to go this way, I go this way, the boat is going to go this way. That is action reaction. So there are some videos to help you with what we are going to be testing over this week. Oh, last thing. Let's talk about graphing. You need to remember that there are 3 different types of graph. There's 3 different graphs. Acceleration will always look like this. However, you need to know which graph, I don't know what I was trying to spell, which graph the straight line equals no motion, and when this one equals constant speed. Also, anytime you have an upward motion, you're going to be speeding up or accelerating. You will also be moving away from the object. Okay, so you have all of your notes. Be sure to look over them closely tonight. And then 6th period will be taking their test tomorrow. And then 7th period will be taking it on Thursday. Have a great evening.